Just a couple things to review about slope. What, for a definition that we could put down, what are some things that you remember about slope? Okay, steepness of the line. Oops. Anybody remember anything else? Any other terms or rise of a run? Good, Brad. Okay. Anything else? Could you give a any other definition, say, of rise? Rise is the change in which variable? So another way you could define slope is the change in y over the change in x. And so when we, now, I'm not sure why we use the letter m, like we have the slope-intercept form, y equals mx plus b. I'm not really sure why we use the letter m, but anyways, when you see m, usually it's going to identify our slope. What's the formula to find the slope? Say if you have 2 points and you want to figure out how steep the line is. That's the slope-intercept. Let's write that down. Okay, that's the slope-intercept equation, and you guys are right. You said y1, and these are just little subscripts. They just identify one y as being different from the other one. So it doesn't matter if you do y2 minus y1 or y1 minus y2. Either way, it's just differentiating between the two. So y sub 1 minus y sub 2. Okay. Now, another thing that I wanted to emphasize was slope. When we talk about a linear function, when you think of it, another way you can think of slope is as something changing. Like, for example, if we think of if I told you that the temperature outside from, say, maybe it's coldest this morning, maybe at whenever it was the coldest. I think they say the coldest time is right before sunrise, if I remember correctly. So if I say the time right before sunrise, say maybe it was 45 degrees, and I said that the temperature is going to be linear, is going to exhibit a linear function as it warms up through the day. What would that mean? Yes, a constant rate, right? So that temperature, I mean, if that temperature went, I don't know, like this, and then just kind of leveled off, would that be a linear change? No. If I say there's a nice slope, that means it just gradually warms up at a consistent slope for the whole until like mid-afternoon, maybe when it gets to be its warmest point. So another way I want you to think of, another thing I want you to know about slope is that we mean consistent change. In other words, you get the same amount. It keeps that constant slope. When you graph those slopes like up 2 over 1 or up 3 over 5, it's consistent. It's the same every time. You get that nice straight linear function. Could you think of any examples of anything, of the other things that have a linear pattern, that you could model them with a linear function? To get to the room here, you actually had to use a linear function. Stairs. In other words, stairs usually are a linear function. It's a consistent change the whole way up, right? There's actually even a, if you were to check the rise and run, stairs, in order for them to be safe and for them to be easier to walk up, they're supposed to be in a certain range for slope. You know, sometimes if you go in a really old house, maybe they'll be really steep. And usually newer houses, you won't find that because they're just not as safe. They're not as easy to walk up and down. Can you think of any other things that have consistent change that could be a linear function? Okay, it could be. You're right. Like if you kind of accelerate at a constant, yes, that could be. Okay. Any other linear functions you could think of? Not many malls have them anymore, but escalators, yeah, those are a linear function. What's that? Up or down? Yeah. That's hard. I guess I wouldn't really call that a linear function just because it's straight up and down. Ladder? It could be. It could be, depending if you're leaning it against something. Okay. Now, this just gives you a little visual of the different, we talked about positive and negative slopes. So the bigger the number, the steeper it gets. You guys, the bigger the number, the steeper you get until you get, so we got a slope of 20, that's kind of the limit there. Now when I change they use C, normally we use B, but we got our zero slope there. Normally we use B, but they're just using C to stand for the y-intercept. What does that change? What does the y-intercept do? What's that going to do to the line? Just moves up and down. So if I do a higher y-intercept, does it change the steepness? No. It just moves it up and down. Not yet. Okay. All right. I just wanted to give you an idea of that. Okay. I'll tell you what. I'm going to wait for tomorrow to show you these ones. Let me show you first. Okay. When you go into the lab, let me show you where you'll find it. You'll go into your applications folder. Okay. Just look in one of the folders and you'll find this green globs here. Okay. And there's a couple things I want you to do. Okay? First off, what I first want you to do, you got to kind of have two assignments with this. First off, when you go under programs, I want you to go right here. We've been talking about linear functions. I want you to go to linear and quadratic graphs. So when you go to that, get here, and then you go to lines. So remember, linear and quadratic graphs, go to lines. I want you to start out, I want you to choose this first option. Begin with easy problems and work up to hard ones. What you do is you get 20 homework points. There's 20 levels. What you do is it just gives you a line, and you just type in the equation of the line. You would just say, yep. What would you say for this one? Y equals 1. Okay. Next level. So when you go through all 20 levels, it'll say at the bottom, congratulations, you've completed all 20 levels. Then just tell me to come over by your computer, and I'll write down your points for completing the 20 levels. Okay. After you do that, then you go to programs. Instead of linear and quadratic graphs, you're going to go to green globs. We're going to, then you choose start a novice game. Okay. What you do, you guys, is when you put in linear equations to smash all the globs on there. When you get all of them off the screen, let me know what your score is. You're trying to get the highest score that you can today. Okay? What's that? Oh, I've had people in like 200s. We're only going to do linear functions, okay? Now, just to show you, we're only going to do the linear ones, though. We'll get to parabolas later. Okay. Let me just take, for example, let's say if I take, these ones here look pretty good. Let's see if I can get those three. If I'm going to do these 2 points here, if I'm going to pick, say, this one and this one, and usually I like to work left to right. So for my slope then, I'm going to either count up and over, or say if I want to do these two, I would just count down and over. Okay? So if I pick these two, that's going to be a slope of, I'm going to go 1, 2, 3, 4. So up 4, over 6. Okay? You could say 2/3, but it doesn't really matter. And what is my y? You kind of have to estimate. What's my y-intercept going to be approximately? You can use decimals. Sure. Let's just say, so my y-intercept is about 1.5. Okay, so let's try that. Normally, if I would ask you for the slope, I'd want you to give it in those terms, but on here it doesn't matter. So we'll just say y equals 46x plus 1.5. Okay. That's how it works. So guys, you got 2 tasks. You got to get through the 20 levels, and you got to get me a green glob score today. No.